Now in class 12th, I am telling you the fourth application of the potentiometer, that is the measurement of thermo EMF by potentiometer. First you have to find that what is the meaning of thermo EMF. इसको हम हिंदी में तापी विद्युत वाहक बल कहते हैं. When the junctions of two different metallic wires like copper iron are at different temperatures. And EMF is developed across the junctions. It is called thermo EMF, and this effect is called Seaweed effect. Seaweed effect. When the junctions of two different metallic wires like copper iron are at different temperatures, an EMF is developed across the junctions. It is called the thermo EMF, and this effect is called the Seaweed effect. This effect was first discovered by Seaweed, so after his name it is called the Seaweed effect. So this is when the junctions of the two different metallic wires are at different temperatures. Suppose you have made a junction of copper and iron, and then the junctions are kept at the different temperatures. Suppose one junction is at the ice temperature and another in the hot water, then a thermo EMF is developed across the junctions. This effect is called the thermo EMF. And this effect, after the name of the scientist, is called the Seaweed effect. So now, if we have suppose this is like this is now suppose copper and this is iron. These are the junctions. This is the junction J1, this is the junction J2. This is at suppose 0 degree centigrade, and this is at suppose 100 degree centigrade. Then a potential, then an EMF is developed across this junction. The thermo EMF is very small, of order of microvolt, microvolt. So this thermo EMF can be measured by the very sensitive potentiometer. The thermo EMF can be measured by a very sensitive potentiometer. For measurement of thermo EMF, the sensitivity of potentiometer is increased by connecting a high resistance in series with potentiometer wire. Potentiometer wire AB. So now let us make the circuit diagram. This is rheostat, this is now key K, this is the cell, and here we have a potentiometer. This is the galvanometer. This is now jockey J. Resistance R. This is the wire AB. Here we make and this is the ice, this is hot water. This is ice. This is your copper, this is iron, and then this copper. and then this is connected to jockey J. This is here the current is passed in the circuit. This is your X, Y and Z. It two-way thing. This is the circuit diagram. This is the main circuit. The main circuit as it is, this is the battery and the key K and rheostat. This is the high resistance that we have connected with series of this potentiometer wire AP. This is a standard cell of known EMF E0, and this is the junction copper and iron. So this junction is at 100 degrees centigrade, means that this is kept in hot water, this is kept in ice. So this is at 0 degrees centigrade. So now this is the circuit diagram of the potentiometer to measure the EMF or the thermo EMF. A standard cell of known EMF and constant known and constant EMF E0 a standard cell of known EMF, known and constant EMF E0 is connected in circuit. This is shown here, and a high resistance. This is the high resistance R. Now this the current is passed in the wire AB. The current from main circuit is passed in wire AB. Now first we connect this XY. so that this cell is in the circuit. The standard cell of EMF E0 is taken in circuit by connecting XY, connecting XY. The current is so adjusted by rheostat that galvanometer shows no deflection. So this is what for XY. When we have connected to so much, then this rheostat RH is adjusted in such a way that the deflection in galvanometer is 0. So now E0, this is equal to I into R, or I equal to E0 upon R. So this we have find out the value of this current. So now the potential gradient X equal to IR upon L. So I is this is R naught. R naught equal to the resistance of wire AB. Resistance of wire AB. So now this X equal to I put here. This is E naught R naught upon. Now this is your R into L. Now this is the potential gradient, and you know that this potential gradient becomes very low due to the high value of resistance R. After it, the rheostat is not disturbed. Otherwise, the potential gradient will change. So this is the standardization of the potentiometer. It is the standardization of potentiometer. Now what we that in the two-way key, the XY is disconnected and YZ is connected. Now XY is disconnected and YZ is connected. The jockey G is slided on the wire AB so that there is null deflection in galvanometer. The jockey J is slided on the wire AB so that there is null deflection in the galvanometer. And let's L equal to balance length of wire. So now thermo EMF. Thermo EMF. This E is equal to what we have, this X into L. So much is the balancing length. X we know it from here. So now if we put this value of X here, then this E can be measured. So this gives you E equal to E naught R naught upon RL into this is now L. This capital L is the length of the potentiometer wire. Length of wire AB. So this we find X and then we find this thermo EMF. Now knowing all the values on the right hand side, the E can be calculated. The thermo EMF can be calculated by measuring the value of different terms on right hand side of the expression. So this is how to measure the thermo EMF by means of the potentiometer. So first what we need, because the thermo EMF is very small, of order of microvolt, 10 power minus 6 volt. So this can be measured only by a very sensitive potentiometer. So just to increase the sensitivity of the potentiometer, a high resistance is connected in series with the wire AB, and then the standardization of the potentiometer is made by means of the current controlled by the rheostat RH, such that the galvanometer shows the null deflection, and then find the potential gradient. Minimum the potential gradient, higher is the sensitivity of the potentiometer. And then again the thermo EMF, the copper iron junctions are taken in the circuit, and then the jockey is slided on the wire AB and find the valence length, and then measure the thermo EMF of the given thermo junctions. So this is how to measure the thermo EMF by means of a potentiometer. So thank you very much.